Hey everybody, I hope that you're doing well. And so what we're going to look at today, this is the second half of section 2.4. So last time we learned how to graph inequalities, we learned how to write interval notation, and we worked on solving inequalities. This time I want to introduce compound inequalities, and then we'll also look at some word problems. Okay? So not a hugely deep lesson here, but some interesting topics. So graphing and interval notation, we already know how to do graphing and interval notation with single inequalities, but what about these compound inequalities? Some people call these sandwich inequalities. As you can see, the x is sandwiched in between two numbers. Well, this makes graphing actually pretty easy because, for one thing, x is going to be so I'm going to shade in between the two numbers. It's really not that hard. So instead of just one number on my graph this time, I'm comparing x to two numbers, -3 and 5. And then we would like to shade in the middle, in between them, because x is sandwiched in between them. Now I do need to put the right symbols on them, so the -3, notice, is an or equal to. So we get the square bracket. While the 5 is a plain less than. So it gets a parenthesis. So that's the graphing. Now, if you do interval notation like I taught you last time, where we read left to right, and you put the number where the shading starts and the number where your graphing ends, this is going to be really simple, because where does the shading start? -3. Where does it end? +5. Then, of course, we need the symbols here. -3 used a square bracket, so I need a square bracket. And +5 used a parenthesis, so I need a parenthesis. So I can graph and interval notate these things pretty simply. Notice I didn't even go to an infinity this time, just 3 to 5. So let's look at another example, just a few more to feel cozy with this. See if I can graph this. Notice x is stuck in between -10 and +7. So once again, those are the only numbers that I need you to put on your graph. And x is in between there, so we're shading in between. Now what symbol do I need for the 10, the -10? It's just a less than. There's no or equal to, so that would be a parenthesis, right? What symbol do I need on the 7? It is an or equal to, so that is a square bracket. So graphing it is pretty easy. Interval notating, where do we start at? As graph starts, we always read left to right. The graph starts at -10 and it stops at 7. And we use the same symbols, a parenthesis and a square bracket. Alright, and last but not least, another example. 2 to 6. X is in between 2 and 6. So those are my two numbers on the graph, 2 and 6. And if I want to shade in here, it's in between them. Notice the 2 has an or equal to, so a square bracket. And the 6 has an or equal to, so they're both square brackets this time. So for my interval notation, the shading starts at 2, and the shading stops at 6. And I use the same symbols as I did in the graph, square brackets. So that's pretty simple. Especially with last time's lesson, we should know how to handle all these things. So even though it's compound and I have more than one part to it, it's just as simple as last time's lesson. Now, what we're going to want to do, though, is solve, then graph, then use interval notation. So notice, let me see if I can make this look a little bit easier to read. Notice that I have an expression in here stuck in between the -1 and the 3. And so what I'm going to want to do is solve just like I normally would. Now remember our rules for solving. Whatever I do to one side, I must do to the other side. The only difference here is I have 3 sides this time. So I'm going to follow that same rule. Whatever I do to one side, the middle here, I'm going to do to the left and the right. I'm going to do whatever I do 3 times. So the first thing to notice is I don't like fractions. Without even worrying about dealing with a fraction, let's multiply everything by 3 to kill off the fraction. And when I say everything, because that 3 is only with a single term, every term has to be multiplied by 3. And this will give us a lot simpler of an expression, because the 3 and the 1/3 will cancel, leave me with just x. 3 times -1 is -3. And 3 times 2 is 6. And 3 times 3 is 9. So there, I still have this expression in the middle with x. I'm still working on solving it. It's not by itself yet. So I just continue. I would normally subtract 6. Now whatever I do to one side, I have to do to all 3 sides. And so if I subtract 6, -3 minus 6 is -9. X is still there. 6's are gone. And 9 minus 6 is -3. So there, I have solved for x. It is all by itself in the middle. So I have this beautiful... Oh, why did I put a negative there? Who let me put a negative there? It is 3. I'm not sure why I put a negative. So I can graph this and write this in interval notation now. Let's see, -9 and +3. It starts at -9 and shades up to 3. And going very quickly here, this is a square bracket, this is a parenthesis because it isn't or equal to, and then it does not have or equal to. And so what would my interval notation be? The shading starts at -9 and stops at 3. Use the same symbols, and there we go. Okay, so it's not too bad. Let's do one more. Once again, noting that I have this expression in the middle and that I'm trying to get x by itself. But whatever I do to the middle, I have to do to the left and to the right. There are 3 sides to work with here. So let's see. Let us 2x plus 5. I need to get rid of the plus 5, so I will subtract 5. Now whatever I do to that term, or that expression, I have to do to all 3 sides. So -3 minus 5 is -8. Bring down your inequality symbol. Bring down our 2x. 5 and 5 is gone. Bring down our inequality symbol, and 11 minus 5 is 6. So we're almost there, but is x all by itself yet? No, we still got this 2 here. So I need to divide everything by 2. Now -8 divided by 2 is -4. I'm left with just x in the middle. 6 divided by 2 is 3. So yay, I have gotten x all by itself in the middle. So I can jump into graphing it. Let's see, I need a -4 and a 3 on my number line. X is stuck in between them. And what sort of symbols are they going to need? This one is not or equal to, this one is not or equal to, so they're both going to be parentheses. Can anybody tell me what my interval notation is going to be without having to trace it? -4 to 3. If you wanted to trace it, you could. Where does it start? -4. Where does it end? 3. You can get really fast at interval notation and graphing without having to take so much time. On the test, take your time. Trace it from left to right. Where does it start? Where does it stop? But you don't have to stress too much here in class. Okay? So solving's not that hard. Even though there's 3 sides, it's the same stuff we've been doing. Graphing's not that hard. Interval notation's not that hard. Okay? So just introducing you to that. The next thing we want to consider are some word problems. Okay? So word problems have a lot of uses for inequalities because usually in life, we're not aiming for something to be equal. We're aiming to be less than something or greater than something. For instance, you have a salary in mind that you hope to make one day when you get out of college, right? You won't have your feelings hurt if you make more than that. What you have is an inequality in your head. You would like to make, whatever 1,000 or more, right? Greater than. Or you may have a minimum age of someone that you will date. You may be, I don't know, if you're a college freshman, you may be 20, 21, 22, I don't know, somewhere, 18, 19. Sorry, thinking of when you graduate. You may say, I'm 19 years old. There's no way I would date anyone below the age of whatever. It's an inequality. Other things. What else? If you make a budget for yourself, you are not trying to spend exactly to that budget. You are trying to spend less than that budget, so you have some money left over at the end. So more things in life fall into inequalities than they actually do equal signs sometimes. So let's look at some examples. For instance, so let's say you're in your ancient Egyptian acupuncture class. Sadly, we do not offer that here at Francis Marion. You have taken 4 tests and you scored 70, 82, 86, and 78. Only the final exam is left to take. The exam counts twice, so that means it counts as 2 tests. What would you need to make on the final exam to earn a B plus in the course? First off, what's a B plus? A B plus is from 85 to 89. So you're trying to see you need a B plus. What do you need to make to be somewhere in 85 to 89 range? Okay. Now, to do this, let us do our normal method for doing word problems. Let's define a variable. What's the question? The question is, what do you need to make on your exam? So let's let x be our exam score. Okay, exam score. So there we go, we got our exam score. Now, let's see if we can write an equation. This equation kind of writes itself a little bit. Let me do some thinking first before we get to writing our explicit equation. You want your overall average to be between an 85 or an 89, right? Aiming for a B plus. So this makes sense then as far as using a compound inequality, which we just learned about, is you want to see what your exam score needs to be in the B plus range from 85 to 89. So all we have to do then is we know it's going to be one of these compound inequalities in between 85 and 89. I just have to figure out how to find this average. Well, think about an average. An average says you add them all up and then divide by how many you have. So let's do that. Let's see, our test scores are 70 plus 82 plus 86 plus 78, and then we have the exam, so plus the exam, but the exam is going to count as 2 test scores, so let's call it 2 times x, because it's going to be like 2 tests. So to find an average, you add them all up, and then we would like to divide by the number that I have. I have 1, 2, 3, 4, and this one counts as 2 tests. So 1, 2, 3, 4, 5, 6. So it's like taking 6 tests. Okay? So there is my equation right there. Okay? They love putting this one on the test. They put it on the test every year, one where you have to average out to do some sort of grade average to make some sort of grade range. Okay? So now let's solve this. Let's do some simplifying. I might actually need a calculator. I don't know if I can do all this in my head, so let me pull up a calculator. Boom. Okay, it's coming just slowly. Alright, let's simplify and let's add these 4 numbers up that are like terms, okay? So 70 plus 82 plus 86 plus 78. I think I got them all typed correctly. 316. So let's 316. So let's write this down neatly. 316 plus 2x over 6, and it's in between 85 and 89. Okay, so let's see if we can solve this. So I've simplified it. Let's see if we can solve it. Right off the bat, you probably don't like that it's a fraction, right? But that is a-okay, because I know how to kill off fractions. I'm just going to multiply by 6. Now, whatever I do in the middle, I need to do to all 3 sides. Now, notice in the middle we get lucky and the 6's cancel. So you just end up with a very simple 316 plus 2x. And I'm going to need a calculator to find these numbers on the end. So let me pull my calculator back up and clear this stuff out. So 6 times 85 is 510. 510. And let's do 6 times 89. And I got 534. Whoops, 534. Okay. So once again, you're allowed a calculator. I would suggest using a calculator for larger numbers like this so you don't make a mistake. Now I just need to solve for x. I can subtract 316 from all 3 sides. And let's see. 316. 510 minus 316. So 510 minus 316 is 194. Less than 2x is less than. And let's see. Come back, calculator. Alright, let's do 534 minus 316. Hope I haven't typed anything wrong in the calculator. I'm very bad at doing that. 218. So now I just need to divide by 2. Divide by 2, divide by 2, divide by 2. So x, your exam score needs to be in between. Let's see, let's clear this out. 194 divided by 2 is 97. Whew, this person's going to need to score high. And 218, well, we know that one in our heads. That's 109. 218 divided by 2 is 109. So this person needs a score in between a 97 and 109. Now, if there's no extra credit, they can't make 109. But that's not for us to decide. We're just telling them what they need to make, or what you need to make on this ancient Egyptian acupuncture's class's final exam. So there we go. And I think usually on this question on the test, they let you leave it as an inequality. We don't have to graph it or interval notate it. Although we could, it wouldn't be hard. I will discuss, we would need to say that these could be equal to's, because an 85, if you equal it, is a B plus, and an 89. So let me add those just to be correct, 100% correct. But on the test, if you did that, I wouldn't take off for it. There we go. Awesome. And so in between a 97 and 109, looking at their test scores, they haven't made any 90s yet. They're probably not going to make a 97, but maybe they could make a B instead of a B+. But, we're just letting this person know. Okay? I hope that makes sense. How I wrote the average, because remember, an average is to add them all up and divide by 6, and how this compound inequality makes sense here. Okay? Let's look at another word problem. So we're going to, on the test, you could do lots of word problems. I think there's all sort of different varieties that could put here, but this is just going to be a simple one where I'm going to have something less than or equal to or greater than or something. Okay, so let's see. We have a delivery truck. So a 3,200 pound delivery truck, so it weighs 3,200 pounds, has to cross an old wooden bridge on its route every day. The old bridge has a max capacity of 4,000 pounds. So if he goes over with too many boxes, he might break the bridge, right? If each package that he carries weighs 27 pounds, we're going to pretend the driver is either counted in this weight, or maybe he doesn't weigh anything. He's really light, just to make this easier. So if each package weighs 27 pounds, how many packages can be carried across in the truck? Okay, so let's think about this. We're looking for how many packages we can have, right? So let's define a variable, x equals number of packages. Alright. And let's see if we can write this. So what do we want to be at less than or greater than? The bridge has a max capacity of 4,000 pounds. So whatever our total weight is, I'm going to just think a little bit again. Whatever our total weight is, we would like it to be less than 4,000 pounds, right? Or equal to 4,000 pounds. Max capacity, if you're at 4,000, that's the most the bridge can hold. Because if our weight goes over 4,000 pounds, we will break the bridge. Okay, now how are we going to find the total weight? First off, we know the delivery truck is 3,200 pounds. Okay. And we're adding packages to it, and each package weighs 27 pounds. Now that is for each package, right? So if I have a package, it will weigh 27 pounds. If I have 2 packages, we will be adding 2 times 27. If I have 3 packages, we will be adding 3 27 packages. So the way we write this is 27 times x plus 3,200, because that's just the weight of the truck, is less than or equal to 4,000. Does this make sense? Do y'all remember back when chapter 2 or chapter 3 we talked about things being rates, because it's for each or per each box? Well, it's for each box. Each package weighs 27 pounds. Okay, so we have written our equation. So we should be able to solve this. So let's subtract 3,200 from both sides. Okay, so 27. Whoops, I can't write a 7. Let me erase that. Try that again. 27x is got to be less than or equal to 800. Okay, so now we're going to divide, and this is going to probably be a decimal. So let's see, 800. Oh, well, let me go ahead and write my work. I need to divide both sides by 27, right? I get ahead of myself sometimes. So x needs to be less than or equal to whatever this is, divided by 27. 29.6. Let's just put that. 29.6. Now, whatever packages he's carrying, he probably can't carry half a package. He's not going to cut someone's, I don't know, whatever he's delivering, not going to cut your bunny slippers in half and just deliver the toe of it, right? So we need to round this answer, okay? We need to round. But I want to be very careful with rounding. We don't need to round in a typical way, because if we were to round this up to 30, how much weight would that be going across? Think about that. If we were to round that up to 30 and carry 30 packages across, say, you can make it across with 30, how much weight would that be? Just do that real quick. Put it in the calculator. 27 times 30 plus, so 27 times 30 plus the 3,200. Oh no, that's 10 pounds over. 10 pounds over. You would break the bridge, right? So anytime you have these with a maximum that you cannot go over, and you get a decimal, we're going to need to round down so that we do not go over. So we're going to say the most packages the delivery driver can carry over is 29. 29 packages. Okay? Because we do not want to go 10 pounds over and risk breaking the bridge. We're hoping that they gave us a bad estimate anyways and it will carry more weight, but man, we do not want to break it. I do not want to get swept away in the river delivering packages. So 29 packages, okay? I hope it makes sense why we need to round down, because if we were to round up, even though when we round, we typically look and say, oh, that's above a 5, it would go up. We want to be extremely careful here, okay? Because it's an inequality. We cannot go over 4,000 pounds, and if we round up, we would be going over 4,000 pounds. All right? Well, awesome. That's all I have for you. I hope that I'll see. Have a good night. Have a good day. I'll see you next time.